Hello everyone, welcome to Learn Overflow. In this video, we'll discuss about today's LeetCode problem. There is a number of submetrics that sum to target. So this is a hard level problem, and we'll understand what this question is asking us to do and how we can solve a question like this, or how we should think on solving a question like this. Okay. So before moving on, make sure to subscribe to this channel for regular LeetCode videos like this. So let's understand what the question is. The question says, given a matrix and a target. So that's a matrix, a 2D matrix, and a target being given to us. And we should return the number of non-empty submatrix that sum to target. So we should return non-entry submatrices that sum up to this target value. Okay. So we should actually return the count of the non-empty submatrices. Okay. Now, like it says, like a submatrix is like x1, y1, x2, y2 is a set of matrix xy, like is a set of all cells from matrix xy. So all the cells from this x1 y1 to x2 y2 are within matrix xy, such that x1 is less than equal to x and less than x2. So that's how this matrix xy holds. Okay. And similarly y1 and y2 holds with matrix like y. Now, further it says the submatrix x1, y1, x2, y2, this submatrix, and another submatrix x1 dash, y1 dash, x2 dash, y2 dash are different if they have some same coordinate. Okay, if they have some coordinate that are different. Achha, okay, so if any of the coordinates, like some coordinate of them are different, then we can say that this is a different submatrix. Okay, for example, that's x1 is not equal to x2, x1 dash. So that's how it's defined. So basically, it means like if a starting question is at any particular point, if one of the coordinate is different, so we can consider that's a different submatrix. Okay. All right. So now I should mention here something that this question, if you are known to this, like this question is actually a 2D format of one of the 1D question previously there in the overlaid code. Okay, so I think you should go ahead and like read through it at least once before like trying to solve this question. So I'll just take you to that question. So that this question is a Savare matrix, Savare sum equals k. So this question is basically, you can say it's a 1D Savare, and in this you will find the sum is also given like this, like a target value is given, and we need to find how many sub arrays are there whose sums are actually equal to target. So that's how we should do. Like that's our target over here. Okay. So if you understand this question properly, then over our question, we can be sure that we just need to go ahead with a 2D dimension of this question. I'll just tell you in short what this question, how we are solving this question. So we are taking a hash map, and we're taking each of the numbers from our nums array given to us. Okay. So this is just an 1D implementation of our particular question, and we should implement our question in a 2D format. So let's understand how we should go ahead with each of the rows, and then we should understand it further. Find our question. We'll get back to our question. Then we, what we did, we just check like if we just found like the sum till this point. Okay, this particular we keep on adding sum, and we check being the target. What is being the target? Target is this k given to us. That's the target value. So we just subtract this k from our sum. Okay, and thus we try to find that if our map contains like a sum till now minus k, that means we have a sum array with some k. Okay, so that's the idea behind this. So if our map contains our target, that means we should increase our count. Okay, and also at the end we should update our sum in the map for the future reference. Okay, that's basically like you are going ahead with say 111 is there. You took this subarray, 11 is 2. You find count is 1. Now another subarray is here. Count is 2. Okay, so it's not count is 3. Okay, the count is 2. That's the idea behind this. Okay, now like that's a one-way or 1D dimensional thought process behind this question. Okay, so let's go ahead and go to our question and try to think of this in our like in a 2D format. Okay, also remember this approach, we just doing what if we are given 111, like 1 and 1 is given. What we try to do, we try to do like 1 is 1, and then we try to sum up this 2, that's 1, and then we try to sum up this 2, that's 2. Okay, then we try to sum up 2 plus 1, that's 3, but target will be 3 minus 2. So 3 minus 2 is that will be 1. So thus I can found that if map contains 1, that means thus we are getting target. So target is if we are getting is at position 1 is something there. Thus we can find out the value in that. So we'll understand in depth in this further in our question also. We'll see how we can approach in our question or the question given to us. Okay, so let's just move back to our question. So in this, what we are doing exactly here. See, in our given example, we are back to our question, by the way. So, in our given example, it's given a matrix like this, okay? A target is given as 0. So, if a target is 0, and we need to find the submatrices that sum to target. So, what are the submatrices? Those submatrices is like this one, and this one, and this one. So, there are the 4 submatrices whose sum is 0. Fine. So, that's the answer is 4. So, that's more or less the idea behind this. So, for a matrix, what is the prefix sum we are looking for? So let's understand first, like what are the prefix sums we are looking for. Let's say we have this particular matrix. Okay, so I'm just clear this right now. We have this particular matrix given to us, and I'll make a different matrix. That's what we call sum matrix. Okay, you can use a different matrix, or you can go ahead with current matrix for find the prefix. But let's draw a different matrix, use a different memory location, and let's understand it first. Okay, fine. Then what comes to us? So here we are given a matrix. Fine. For our matrix, let's first understand what is the submatrix sum being equal to. Fine. Say we have a matrix like this. Okay. Say we have a matrix like this, and we have a matrix like this. Okay. Fine. Now, if we are saying saying our sum matrix, this particular matrix, if it's saying like this particular column is say xy coordinate is there, fine. Xy coordinate being this coordinate, and this particular coordinate is 0 0, fine. 0 0, and this particular coordinate over here is xy coordinate, fine. Now let's try to understand if we're saying our matrix is starting from 0 0, like our matrix is starting from 0 0, and what is the sum of our matrix? Like what is the submatrix that sums up to xy? If we're telling that, that means we need to keep a sum of this. We need to keep a sum of this. Okay, let's just modify the question because that will be easier to understand. Modify the question in the what I mean is let's not take xy being the last coordinates. Okay, let's just take xy being a coordinate like this. Fine, a coordinate like this, and this is xy. Fine, somehow in between. Fine. So when you're telling xy being somewhere in between, so what do we mean when we say the submatrix xy like 0 0 till x? So that basically means we need to sum this box, sum this box, this particular one, there, and there. So from 0 0, starting from 0 0, if we take a submatrix till xy, that means we are taking a sum of all these boxes. Okay. Alternatively, if I just erase this and say if I just try to mark that if our submatrix was something like this, fine. If our submatrix was something like this, then this coordinate is x1. So in that case, what will be our submatrix, or which are the cells we should count? We should count this one, over this, this, and this, and this. So those are the cells we are counting. Fine. So I think you can understand whenever we are starting from 0 0 and we are saying we are at xy. So that is what does we actually mean, or what does we are doing over here. Fine. Now the next steps for us would be to just go ahead with the same concept we did in our the other question I told you. Okay. So what we'll do over here, we will try to find out, like we'll try to calculate the sum of all the submatrices whose upper left corner is 0 0. Okay. So we'll try to find out the sum of submatrices. Okay. Which whatever is starting from 0 0. Now for that, we first need to go ahead with the prefix sum concept. Prefix sum is the exactly one that we saw in the other question. Fine. So what it will do, we will say we are taking this particular matrix. Fine, we are taking this particular matrix and we are trying to find a prefix sum out of it. So for that, what we'll do, we'll go ahead with a row wise column, like each of the line prefix sum for each line. Fine. So in each case, so you can start like 0 1 and then 0. Fine. Then whenever at this box means we'll make a sum of this and this. Fine. So that's 1. And whenever we are at this box, we are making sum of this and this. So that's 2. Fine. That's 1 plus 1, 2. And then whenever we are at this box, we'll make a sum of this and this. That's 1 plus 1, 2, 0 plus 1, 1. Now, whenever we are at, then we come across this box, we'll make a sum of this. That's 1. Not basically 0 plus 1, rather 0 plus this value out here. Okay. Like sum of ij minus, I like of the sum matrix value added to the current value of the our given matrix. Okay, so that's what we are doing. Next, we are doing 1 plus the last value being 2. So that's is 3 over here. Fine. Next is 0 plus the last value. Last value over here is 1. So 0 plus 1 is 1. Now, look carefully. We just calculated the prefix sum. That's the exactly same thing we are doing in our last question. Now, we need to go ahead in a 2D format. Fine. For that, we will keep an additional left column for us, like additional left column for easier calculation. So this will be 0, 0, and 0. We are not considering this anyway. This is in our additional matrix. Okay. So just for additional help, we'll see how this can help us. Okay. Now, using this prefix matrix of each line, we will go ahead and calculate the sum of the submatrices. Okay. So whenever we are seeing sum of submatrices, that means we are going to keep a sum of all the submatrices. Fine. What does it mean? It basically means, see, if we are going ahead with something like, look over here, we are going ahead with 0, 1, and 0. So that's basically, if we are saying submatrices, that means 0 and 1, 1, 1 and 0, like here it will be changed to 1. Okay. So that, like, submatrices in the format, like we will take a whole count over here. Fine. That's the sum of submatrices. We'll keep on counting. Say we are going ahead with sum of 2, 2, sum of say 2, 2. Fine. 2, 2 being out till here. So that basically would mean, no, not outside, 2, 2 mean out here, like it starts from 0, 0, right? So that if you say 2, 2, that means sum of 2, 2 itself, plus sum of 1, 2, 5, 1, 2, 2, 2, 1, 2, and a sum of we'll say 0, 2. So you can see, like, keeping our like row, like column constant, we're just keeping the changing our rows. So that's a sum we are next calculating. Like, we'll keep on calculating, then that will be our next thing. Okay. So like, up next, what we'll do, we'll now find the sum of each of the submatrices, like sum of all the submatrices, because like till now what we are doing was, we consider that we started from 0, 0. So we are trying to find the sum of like, the format is like, we just found a sum, whatever sum is, it's till this position. Okay. It's all starting from 0, 0. It's not starting from anywhere, because if all starting from 0, 0, then we can find that the 0 is like, if we need to reach a target of 0, that's given over here. So in that case, we can reach only one value, that's the sum of 0 given to us. Okay. So in that case, what we'll do, we'll again come up to the same map concept, hash map, that we used in our last question. I have shown you, right? So we'll use the same concept, and we'll try to keep a map of all the matrices that can be possible from here. Okay. So how can we find the sum of all submatrices? For that, like, any submatrix needs to be any two rows and any two column to form a submatrix, right? Like this, to say that the 4 variables and the 4 nested loops are required for this particular operation. Up next, we'll just convert this 2D matrix to kind of an 1D matrix, so that we can go ahead and like, we'll keep a start and end. Like, the start is different position and end is different position. Like, we'll keep a we'll not go ahead with the like 4 in nested loop. Rather, we'll keep 4 variables to keep a track of the particular values we are trying to operate. Okay. So I'll just write the code and make you understand further, like, what I exactly mean when I say this step by step. So just understand this thing step by step, and after that, when I'll explain the code again, you'll be able to visualize this whole concept over here. Fine. So next thing will be, we will simply like, we need to transform our particular array. Okay, this particular sum matrix, transform like the 90 degrees to the left. So 90 degrees will transform this particular matrix, and then you will see that the problem is like, how many sub arrays whose sum is equal to target. So that will be the ultimate target, ultimate goal will be reaching. And then in the same way, we can use like a hash map, as I was telling you, to optimize this double nested loop that we are doing, to just run from here till here. Like, it's running from 0 to end. That's the initial nested loop, and from any point start to any point end, it will be like a double nested loop. So to minimize that, we will use a hash map to just keep a count of all the stuff, and thus we'll reduce that double nested loop to a only one. Fine. So that will be the idea of the idea over here. Fine. So just let's go ahead and write this code, and then let's try to understand, like, how exactly this particular thing works for us. Fine. So then you can actually visualize this particular thing. I will again explain you the same thing after writing the code. All right. Okay, so here we can see that this question works, and now I'll explain again what we did exactly. The first thing, the first thing you can say, we just take the initial variables like x1, y being the length and breadth, and then we found an answer. Answer being the last answer will be returning over here, fine. And also we took a hash map for reducing a complexity. Now, what further we have? We have over here is like we initially I saw you like we are taking the prefix sums, right? On each row. Each row we are doing a sum, and that's what we did over here. See, for each row we are doing a sum of the last element. Okay, so for each of the row we did a sum of the last element over here. So that's how the matrix will look like over right now. Further, we started like a row from 0 to x, and then current j, like j group of j, so j to x. Okay, from both sides. So what we try to do, like now we are doing basically not start like initially the start is from 0 0, but further we keep a check that our start is also not from 0 0. It keeps us on starting from some other values or some other matrix elements. Okay, so that's the idea of it. Now what we did, we simply did res.put. Res.put mean we just took some initial values like 0 comma 1. There's a target is 0 and like value is 1. So we just put something in it. Fine. Now, further, we just kept on checking. Like we found a sum. We took all the matrix, like the current, the thing we're doing. We are checking for the column wise, right? I just showed you like we should go by the sum of 2 2. If we're saying then sum of 2 2, then 1 2, then 0 2. So those are some I just shown you before. So in that way, we just took a sum being a sum of our current value and value minus 1. So what we did here, if j is greater than 0, in that case we will go ahead with the value minus 1, and if j is 0, then we know that there's nothing previous to that, so we just add a 0 to it, and that's how we end it. Now the idea is the sum we found over here, fine, and the sum we found over here, and in this what we are going to do, we are checking for the target, like sum minus our target. If we reach our target, then our answer is getting incremented. In case we are not, then it is as incrementation is default value is 0. If we get our sum minus target is a key of in our particular map, then we increment that. Okay, and ultimately we do what, we just add this current sum to our map. Okay, we just make it like if it's default value, then 0 plus 1. In case else, if it has a value, then we just increment that value. So we just keep on doing that. That's the exact same way. If we just remember, look here in our the easier one, in the same 1D question, we are doing that same exact thing. We just add, like we just counted that if we can get this, so we in sum minus k, that's k being the target over here. So sum minus k, we just took like in a different variable, and then found checked whether this is in the map or not, and ultimately we just put the same thing in our map. And the exact same thing we're doing over here. We are finding that if a sum is there, like we are finding the sum, and ultimately we are finding if the sum is sum minus target is there in our map or not. If it is the map, then we add it, or else it's a 0 we are adding, and then putting it back into our mapping. So that's and finally we're just returning the answer. So that's how the questionnaire exactly works for us. Fine. So that's all about this question, guys. So I hope I can make you understand how to solve a question like this. If you have any doubts or anything you cannot understand, make sure to comment down below. I will be happy to help you out. Also, subscribe to this channel for regular LeetCode videos like this. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.